Dear students, welcome. This is our 15th class on statics. First, we shall try to solve these three problems. Question number 4, today's question number 1. P and Q are two like parallel forces. If P is moved parallel to itself through a distance x, so that the resultant moves through a distance this one. Suppose P and Q are like parallel forces. P and Q are like parallel forces. P and Q are acting at the point A and B. Their resultant, suppose their resultant is P plus Q. P plus Q is the resultant acting at the point C. Now, if P is moved parallel to itself, line of action of the parallel to itself through a distance x. This distance is x. Suppose this is L. X. Then if P is acting at the point L and Q is acting at the point B, then their resultant will be acting at the point D, suppose. This is the new resultant. New resultant. New resultant is again P plus Q. P plus Q. I am writing new resultant. Then the resultant moves through a distance this. Means we have to find the distance CD. Find the distance CD. Let me write parts like this. Let P and Q are two like parallel forces acting at A and B respectively. Let P and Q be two like parallel forces. Like parallel forces acting at A and B respectively. A and B respectively. Acting at A and B respectively. Their resultant will be P plus Q. Their resultant acts at the point C. Let their resultant is obviously P plus Q. Acts at C such that acts at the point C such that P into AC equal to Q into BC. P into AC equal to Q into BC. Suppose this is number 1. PAC equal to Q into BC. Second part. Come to the second part. If P is moved parallel to itself, suppose the line of action of the force P is shifted to the point L. Let the line of action of the force P be shifted to the point L. Point L such that I am writing here such that AL this is equal to X. This means P and Q are parallel forces. This time P is acting at the point L and Q is acting at the point B. At the point B. Let their resultant be acting at the point D in this case. Now, let the resultant of the forces be shifted to the point L. Now the resultant. Now let the resultant. You may write let the resultant. Of two like parallel forces. Like parallel forces P and Q. This time acting at L and B respectively. Acting at L and B. Acting at L and B respectively. acting at L and B respectively acts at D. What is this? Resultant of two like parallel forces P and Q acting at L and B respectively means P is acting at the point L and Q is acting at the point B. Acts at D means the resultant of these two forces acts at D. Where such that you may write such that P into LD equal to Q into BD. Q into BD. P into LD equal to Q into BD. It will be like this. Let me write the number 1 here. P into AC equal to Q into BC. Write number 1. Let me do this means, see the diagram, LD can be written as LA plus AD. LA plus AD. This is equal to Q, BD. We have to find the value of CD. Therefore, BD can be written as BC plus CD. BC plus CD. We have to find CD. This means P into LA, LA means X, plus AD. AD can be written as AC minus CD. AC minus CD equal to Q into BC. Plus Q into CD. Q into BC plus Q into CD. You may write this. Right. This means that PX plus P into AC minus P into CD equal to Q into BC plus Q into CD. Q into CD. Now, PAC equal to QBC. PAC equal to QBC by 1. This means PX minus P into CD equal to Q into CD. Using since P into AC equal to Q into BC. Q into BC by 1. Using 1, these two terms can be cancelled. This means P plus Q into CD equal to, I am writing here, equal to PX. This means CD equal to, this means CD equal to PX divided by P plus Q. PX divided by P plus Q. Therefore, the resultant moves through a distance this. This means that in this case, if P is shifted to this, P is moved in this direction, then the resultant will move through a distance Px divided by P plus Q in the same direction. Therefore, the resultant moves through a distance resultant moves through a distance Px divided by P plus Q. Px divided by P plus Q. Hence proved. We have done the question number 4. We have done the question number 4. 4 has been proved. Let me remove the 4. Question number 4. It has been proved. Now come to the question number 5. To unlike parallel forces P and Q, P is greater than Q. Magnitude of P, the force P is greater than the magnitude of the force Q. On two points at a distance x apart, so that if the direction of P be reversed, the resultant is displaced through a distance this. Now this time the unlike parallel process. The parallel process, unlike parallel process. Suppose P and Q are two unlike parallel process. P is acting at the point A and Q is acting at the point B. Q is acting at the point B. Unlike parallel process. Therefore, P is greater than Q. Therefore, their resultant will be acting in this direction. The resultant of P and Q will be P minus Q, will be acting at C, such that P into AC equal to Q into BC. 2 points at the distance x apart means AB equal to x. AB equal to x. Second part, see the second part. Show that if the direction of P is reversed, in the second case, if P is acting in this direction, then P and Q will be like parallel process. Their resultant will be acting in this direction. Resultant will be P plus Q. In this case, it will be like parallel process. Suppose the resultant acts at the point B. Then the resultant is displaced through a distance. Means in this case also we have to find the distance CD. In the first case, the resultant was acting at the point C. In the second case, the resultant is acting at the point D. Resultant is displaced through a distance. What is this? CD. We have to find the value of CD. Let the two unlike parallel process P and Q. Let the unlike parallel process P and Q. Let the unlike parallel process P and Q be acting at the point, A and B respectively. Where AB equal to x. It is given. Where AB equal to x. It is given in the question. Now, let the resultant of this unlike parallel process, what will be this? P minus Q. Let the resultant P minus Q of this unlike parallel process be acting at the point C. Such that P into AC equal to Q into BC. From the first condition, when P and Q are unlike parallel process, P is acting at the point A and Q is acting at the point B. These are two unlike parallel process. Therefore, the line of action of the resultant will be in this direction, as shown in the figure. The resultant will be P minus Q. At the point C, therefore P into AC equal to Q into BC. Just you know it. Come to the second point. What is the second point? If the direction of P is reversed, if the direction of P is reversed, if the direction of P is reversed, then the process P and Q will be like parallel process in this case. Then the process P and Q will be like parallel process. Like parallel process. In this case, let their resultant P plus Q will be acting at D. Let their resultant P plus Q. In this case, the resultant will be P plus Q, like parallel process. Let their resultant P plus Q will be acting here at D. Will be acting at D, where P into AD equal to Q into BD. P into AD equal to Q into BD. Now we have to find the distance CD. We have to find the distance CD. This is number 2, suppose. Let me write the number 1 here. P into AC equal to Q into BC. This is number 1. Number 1. Now 2 from 2, P into AD. See the diagram. What is AD? CD minus AC. You may write CD minus AC equal to Q into BD. AB minus BD. BD means we have to find the value of CD. You remember it. BD means BC minus CD. BC minus CD. BC minus CD. You may write like this. This means we have to find the value of CD. P plus Q into CD. P into CD, here Q minus Q into CD. If you take the minus Q into CD from right side to left side, you will get plus Q into CD in the left side. This is equal to P into AC plus Q into BC. P into AC plus Q into BC. This means that P plus Q into CD equal to P into AC. P into AC plus another P into AC, you may write like this, by 1, using 1, by 1, or using 1 you may write. This means that P plus Q into CD equal to 2 times of P into AC. In the question, see the question. CD is expressed in the form twice PQ by P square. P and Q may be there, and X is there. X, what is X? AB equal to X. Means you have to express AC in terms of PQ and AB. It is AC. Just replace AC by AB. How can you replace AC by AB? Now, suppose this is number 3. This is number 3. AC from 1 implies, suppose from 1, P by Q equal to BC by AC. You may write BC by AC. What is BC? AC plus AB. This means P by Q equal to AC plus AB divided by AC. Thus you can express AC in terms of AB. This means P by Q equal to 1 plus AB by AC. You may write like this, AB by AC. What is AB? AB is equal to X. Or P by Q minus 1 equal to X divided by AC. Since AB equal to X, AB equal to X. This means that P minus Q divided by Q equal to X by AC. This means AC equal to QX divided by P minus Q. Px divided by P minus Q. Suppose this is number 4. Using 4 in 3 we get. Now using 4 in 3 we get. Using 4 in 3 we get. 4 in 3 we get. 4 in 3 we get. P plus Q into CD. This is equal to twice P. What is AC? QX divided by P minus Q. QX divided by P minus Q. This means CD equal to twice PQX divided by P plus Q into P minus Q. This means that CD equal to twice PQX divided by P square minus Q square. Therefore, the resultant is displaced through a distance this, where X is equal to AB. AB equal to X. Therefore, the resultant, if the direction of the force P is reversed, then the resultant will be displaced through a distance twice PQX divided by P square minus Q square. Therefore, the resultant will be displaced through a distance. Displaced through a distance twice PQX divided by P square minus Q square. Resultant is displaced through a distance if the direction of P is reversed. Initially, the forces P and Q were unlike parallel forces. When the direction of P is reversed, then the forces P and Q become like parallel forces. Then the line of action of the resultant will be displaced through a distance twice PQ divided by P square minus Q square into AB. For AB, you may write X. Therefore, this problem has been solved. We have done question number 5. Now come to the last question. Question number 6. Question number 6. Let me remove this one. Question number 6. What is question number 6? If the magnitude of two unlike parallel forces P and Q acting at A and B of a rigid body be increased by the same amount as, here vector sign is not given, means the magnitude, yes, this magnitude is added, magnitude of P is added by S, means the force P will become P plus S and Q will also become Q plus S. So that the line of action of the resultant will move further off from P a distance this one. Let me try. Right? Unlike parallel forces, P and Q are unlike parallel forces. greater than Q. Unlike parallel forces, A and B are acting at the point A and B. Increased by S. Suppose C is the line of action of their resultant. C is the line of action of their resultant. The resultant is P minus Q. And second part is this: magnitude of P and Q are increased by the same amount as. If it is P plus S and it is also Q plus S, then the resultant will be acting at the point D, suppose. At the point D. Further from A at distance is shown. In terms of AB, we have to find the distance. Right? Let the resultant of two unlike parallel forces. Unlike parallel forces, P and Q, P is greater than Q, means magnitude of P is greater than magnitude of Q. Be acting at the point C. Be acting at the point C. Be acting at the point C. Such that P into AC equal to Q into BC. P into AC equal to Q into BC. Suppose number 1. This is number 1. Second part. Come to the second part. If the magnitude, if the magnitude of P and Q are increased by S, then let their resultant will be acting, then let their resultant X at the point D, X at the point D, resultant X at the point D, where point D is such that, you may write such that P plus S into AD equal to Q plus S into BD. We have to find the value of CD. AD can be written as CD plus AC. P plus S, AC plus CD. AC plus CD, you may write Q plus S, BD, BC plus CD. You may write BC plus CD. Or P plus S minus Q plus S, CD. These two terms. P plus S, Q plus S. Plus P plus S into AC. This is equal to Q plus S into BC. Q plus S into BC. This means SS will be cancelled. P minus Q CD. P minus Q CD plus P into AC plus S into AC. This is equal to Q Q into BC plus S into BC. S into BC. S into BC. Now, PAC equal to QBC. This means P minus Q CD plus S AC. This is equal to S BC. PAC QBC can be cancelled by 1. Since PAC equal to QBC by 1. This means P minus Q into CD equal to S BC minus AC. This means P minus Q into CD equal to S. See the diagram. BC minus AC. BC minus AC will be equal to AB. This means CD equal to SAB divided by P minus Q divided by P minus Q. Therefore, the line of action of the new resultant will be acting at the such that CD equal to this. Means the resultant, if P and Q are added, magnitudes of P and Q are added by the same amount as, then the resultant will move further from P a distance S into AB divided by P minus Q. We have solved all the 3 problems. Let me, we are going to solve some more problems. First, let me remove this one. Then, let me try to solve these 2 problems. 2 problems. Question number 7. Two like parallel forces P and Q. No vector sign has been given here. This means that the magnitude of the force P vector is equal to P. P and Q act at the given points of a body. If Q be changed to P square by Q, so that the line of action of the resultant is the same as it would be if the forces were simply interchanged. Suppose P and Q are two like parallel forces. P and Q are two like parallel forces acting at the point A and B respectively. P and Q are two forces like parallel forces acting at the point A and B respectively. Their resultant be acting at the point C, suppose. Resultant will be definitely P plus Q will be acting at the point C. So that P into AC equal to Q into BC. Now, first, if we interchange the forces, if we just interchange the forces, then what will be the line of action of the resultant? Suppose Q is acting at the point A and P is acting at the point B. Then the resultant Q is acting here this time and the P is acting here this time. Then the resultant will be acting here. Suppose this. This is the new resultant. It will be new resultant. New resultant. Let me first write. Let the two like parallel forces P and Q acting at A and B respectively Two like parallel process, P and Q, B acting B right and B acting at A and B respectively. Let their resultant be acting at the point C. Let their resultant acts at C such that acts at C in such a way that P into AC equal to Q into BC. You will get this one. Suppose this is number 1. You will get P into AC equal to Q into BC. Now, if the forces are intersensed, simply intersensed. Now, if the forces are intersensed, that is if this time P and Q are acting at the point B and A respectively, that is if P and Q are acting at B and A respectively, then let their resultant be acting or acts at the point B. Such that Q into AD equal to P into BC. Such that QAD equal to P into BC, BD, Q into BD. You get this one. What is AD? Just find CD. This means Q into AC plus CD equal to P. BD means BC minus CD. BC minus CD. This means P plus Q into CD, P plus Q into CD plus QAC equal to P into BC. P into BC. You will get this one. CD. Am I right? AD. P, Q into AD. AD means AC plus CD and P into BD means BC minus CD. Therefore, P into BC minus Q into AC. This means in terms of AB, you write in terms of AB. Now, from this, P plus Q into CD plus Q, what is AC? AC equal to AB minus BC. AB minus BC. AB minus BC. This is equal to P into BC means AB minus AC. P into AB minus AC. AB minus AC. This means P plus Q into CD plus QAB minus QBC. This is equal to PAB minus QBC, QAC. Now, no, not QAC, it is PAC. PAC equal to QBC. these two terms will be cancelled by 1. This means P plus Q into CD plus Q into AB equal to P into AB. Since PAC equal to QBC, these two terms can be cancelled by 1. By 1, therefore we have cancelled these two terms. P into AC equal to Q into BC by 1. This means that CD equal to CD will be equal to P minus Q AB divided by P plus Q AB. Suppose this is number 2. CD equal to this. If, what is it? If the direction, if the positions of the forces P and Q are simply interchanged, then the resultant is displaced through a distance this. P minus Q by P plus Q into AB. This means that. Now, see the question. This time we will do it if Q is changed to P square by Q. P is changed to P square. P is changed to P square by Q. P square by Q. Let now Q is changed to P square by Q. P square by Q. Then let the resultant of the forces P and P square by Q. P square by Q. Thus we have written the relation with the forces P and P square by Q be acting, or let the resultant X at the point E. Point E of AB. E of AB. Means here A and B are the same thing. P and Q are acting at the point initially A and B. The resultant was acting at the point C, and P is unchanged. P remaining unchanged, and Q is changed to P square by Q, acting at the point A and B. Suppose in this case the resultant will be acting at the point E of AB. E of AB. Such that P into AE equal to P square by Q into BE. P square by Q into BE. AE means, now this time find the value of CE. This means P into AE means AC plus CE. AC plus CE equal to P square by Q. BE means BC minus CE. BC minus CE. BC minus CE. This means P plus P square by Q CE plus P into AC equal to P square by Q into BC. You will get this one. You will get this one. This means P by Q. You may write here P plus Q into CE plus AC. P into AC by 1, P into AC equal to Q into BC. You may write Q into BC. Q into BC equal to P square by Q BC. Since by 1 or using 1, you may write using 1. What we have used from 1, P into AC equal to Q into BC. In place of P into AC, thus we have written Q into BC. We have written the bracket so that you don't get any confusion. Q into BC. This means P by Q, P plus Q, CE should be equal to P square by Q minus Q into BC. Q minus Q into BC. Or P by Q, P plus Q into CE should be equal to 1 by Q. P square minus Q square into BC. You may write like this. This means P by Q, P plus Q into CE should be equal to 1 by Q, P plus Q into P minus Q into BC. Q into BC. P plus Q can be cancelled because P plus Q is not equal to 0. Q is not equal to 0, therefore you may write here P into CE should be equal to P minus Q into BC. P minus Q into BC. P plus Q is not equal to 0, just divide it. And Q is not equal to 0, divide it. Multiply. Since P plus Q is not equal to 0. Also Q is not equal to 0. Therefore, just cancel, you may cancel this one. Write BC in terms of AB. Now you may write BC in terms of AB. From 1, P into AC equal to Q into BC. From 1, you get P into AC equal to Q into BC. From 1. This means P, AC means AB minus BC equal to Q into BC. Q into BC. This means P into AB equal to P plus Q into BC. This means BC equal to P into AB divided by A plus Q. Well, P plus Q divided by Q plus Q. And this is number 3. P into CE equal to P minus Q into BC. And suppose this is number 2. This is number 2. Now, using 4 in 3 we get. Using 4 in 3 we get. In 3 we get P into CE equal to P minus Q P AB divided by P plus Q divided by P plus Q. This means there PP will be cancelled. CE equal to P P minus Q divided by P plus Q into AB. Suppose this is number 5. From 2 and 5, we get, this is CD, P minus Q by P plus Q AB. CE, P minus Q by P plus Q AB. From 2 and 5, it is clear that D and E, the 2 points D and E are the same point. From 2 and 5, it is clear there. From 2 and 5, it is clear there. Clear there. The points D and E are the same. Same point. This means that if the forces P and Q are simply interchanged, their positions, simply interchanged, then the resultant will turn through a, or will be displaced through a distance P minus Q by P plus Q into AB. In a similar manner, if the force Q is replaced by P square by Q, then also simply, and P is taken as it is, then the resultant will turn through the same distance, will be displaced, the resultant will be displaced by the same amount, that is P minus Q by P plus Q into AB. Therefore, we have proved this one. Question number 7. If Q be changed to P square by Q, so that the line of action of the resultant is same as it would be if the forces were simply interchanged. Hence, we have proved this one. C and D and E are the same point. What is the point D? If the forces P and Q are simply interchanged, then D is the line of action, D is the point of action of the resultant of the forces. The new forces, if P and Q are just simply interchange their positions. If Q is replaced by P square by Q, then also the resultant will be acting at the same point. We have proved this one. Perhaps you have understood this one. We have done question number 7. Now come to the question number 8. What is this? Come to the question number 8. Question number 8. What is this? So that the resultant of 3 equal parallel forces, also like parallel forces, acting at the vertices of a triangle, passes through the centroid of the triangle ABC. This means that ABC is a triangle. 3 forces equal forces, not only equal and like parallel forces, not only equal, like parallel forces. Suppose P and P, the forces acting at the vertices ABC of the triangle ABC. Suppose there are 3 equal like parallel forces. P and P are acting at the vertices A, B and C respectively of the triangle ABC, of the triangle ABC, respectively of the triangle ABC. Triangle ABC. Like parallel processing. Let us suppose that D is the middle point of BC. D is the midpoint of A. Let D be the midpoint of. Let D be the middle point of BC. Join AD. Let us join AD. Join AD. The resultant of the forces P and P acting at B and C respectively. B and C respectively, the resultant of the forces respectively will be twice P. This is what you will write here like this. And it will be again like parallel process. P into BD equal to this P into DC. P into BD, P into DC. And it will be again like parallel process. And it will be means the resultant again like parallel force. Like parallel force. Now the resultant of the forces P and twice P acting at A and D. These are two also like parallel forces. Now the forces P and twice P acting at A and D respectively are also like parallel forces. Let their resultant be acting at the point Z. Let their resultant what is the resultant? Thrice P. The magnitude is thrice P. The their resultant acts at the point Z. Such that P into AZ equal to twice P into DC. P into AZ equal to twice P into DC. This means AZ equal to twice DC. This means AZ divided by DZ or ZD. AZ by ZD equal to 2 divided by 1. Therefore, AZ is to ZD equal to 2 is to 1. Therefore, Z is the centroid of the triangle. Therefore, G is the centroid. Therefore, G is the centroid of the triangle. Of the triangle ABC. That is the resultant of P and twice P. That is, what is twice P? Twice P is the resultant of P and P acting at B and C. That is the resultant. That is the resultant. Then of P and twice P. And twice P acting at A and D respectively. Respectively. X and D. X at the point Z. Point Z. What is D? What is twice P? It is the resultant of P and P acting at B and C. That is the. This means that. You may write. This means that the resultant of the three forces. Resultant of the three forces acting at A, B and C, three forces P, P, P acting at A, B, C vertices A, B, C acting at A, B, C at the vertices A, B, C of the triangle ABC. This means that the resultant of three forces PPP acting at the vertices ABC of the triangle ABC passes the resultant. This resultant passes through the centroid. Through the centroid G of the triangle. Centroid G of the triangle. ABC passes through the centroid G of the triangle ABC. We have solved the question number 8. Let me solve one more problem. First, let me remove this. Let us try to solve these two problems. Question number 9 and question number 10. What is question number 9? Three like parallel forces PQR act at the vertices ABC of a triangle ABC and are respectively proportional to ABC, small a, small b, small c, so that their resultant passes through the incenter of the triangle ABC. Incenter. Suppose this let me write like this. Okay. ABC. Suppose ABC is a triangle. Three like parallel forces P, Q and R Q like parallel forces. Oh. You just write like this. P, Q and R. These are the like parallel forces. Acting at the vertices A, B, C of the triangle A, B and C of the triangle ABC. Like this. Suppose this is I. It is T. Like this. Let the like parallel forces P, Q and R acting at A, B and C respectively of the triangle ABC. Let the PQR, you may write here, are acting at the point at ABC respectively of the triangle ABC. Now the resultant of, let the resultant Q plus R of the forces of the like parallel forces let the resultant Q plus R of the like parallel forces Q and R acting at B and C respectively acts at the point D of BC, at the point D of BC. Therefore, we must have Q into BD equal to R into DC. Q and R are two like parallel forces. These two like parallel forces are acting at the point B and C. Their resultant will be Q plus R. The resultant will be acting at the point D, suppose. Then Q into BD equal to R into DC. Or BD divided by DC. BD divided by DC. Or you may write here BD by or DC or CD is the same thing. Therefore, R into CD, BD by CD equal to BD by CD equal to R by Q. Suppose this is equal to R by Q. Also, PQR, magnitude of PQR proportional to ABC also given there. Suppose this is number 1. Also, P is to Q is to R should be equal to A is to B is to C. What is small a, small b, small c? This is ABC. The side opposite to angle A is small a, it is small b and small c. Means P by A equal to Q by B equal to R by C. This means R by Q equal to C by B. What is C? C is equal to AB. What is B? B equal to AC. B equal to AC. Suppose this is number 2. There 1 and 2 implies, this implies BD by DC, BD by DC or CD, CD should be equal to AB by AC, AB by AC. BD by DC equal to AB by AC. This means AB bisect the angle, that is, therefore the line AD bisects the angle BAC, the angle BAC, it bisects the angle BD by DC equal to AB by AC, therefore the line AD bisects the angle BAC, bisects the angle BAC. Now, now the resultant of P and Q plus R, up to this it is clear, I think. Now the resultant of P and Q plus R acting at A and B respectively, resultant of like parallel process, you may like parallel process, A and B respectively, will at some point on AD, will at some point on AD. That is, the resultant of P, Q and R will act, this is the bisector, will act at the bisector of the angle BAC, You may write here, that is the resultant of PQR acting at ABC, C respectively of the triangle ABC, The resultant passes through the bisector of the angle, passes through the bisector of the angle BAC, In a similar way, we can say that the resultant of in a similar way, you may write here, in a similar way or similar manner, it can be proved that the resultant of PQR or the resultant of Q and P plus R. P plus R. The resultant of P and R will be P plus R. It will be P plus R. Join, suppose this is point E. Join BE. Then will also pass. Through the bisector of the angle. Then through the bisector of the angle ABC. Through the bisector of the angle. Bisector of the angle ABC. Angle ABC. This means that the resultant of P, Q and R must pass through the incenter. Must pass through the incenter. Their point of intersection will be the incenter. Therefore, the resultant of PQR will pass through the incenter of the triangle. Incenter I of the triangle ABC. Clear? Means the resultant will pass through the bisectors BAC, CAB, BAC, ABC and BCA. All the bisectors. Resultant will pass all the bisectors of the angles of the triangle. This means that it passes through the incenter of the triangle. Will pass through the incenter of the triangle. We will also pass through the bisector of the triangle angle ABC, and similarly BCA also. You may write here BCA also. That is the resultant of PQR will pass through the incenter of the triangle. Resultant will pass through all the bisectors of the angle A, B and C. This means that it must pass through the incenter of the triangle. Perhaps you have understood this one. This is not so tough, it is very easy. Now try to solve the question number 10. What is question number 10? Try to solve the question number 10. What is this? Like parallel process P and Q at the points L and M of a rigid body. L and M of a rigid body. P and Q. F and L and M respectively. Their resultant meets L and in M. The resultant is P plus Q in M. When the forces are interchanged, Q force is acting here and P force is acting here. Then the resultant meets Lm in G. Where Ln is equal to Mg. This time resultant is Q plus P. We have to show that P is equal to twice P. P is equal to twice P. Now, resultant of P and Q. The resultant P plus Q of P and Q acting at L and M acts at M. Therefore, P into Lm equal to Q into Mn. Q into Mn. This is number one. Also the resultant Q plus P of Q and P acting at L and M respectively acts at Z. Therefore, Q into LZ equal to P into MZ. This is number two. From these two relations, we have to show that P equal to twice Q. This means we have to find the relation between P and Q. It is given that Ln is equal to Nz. Ln equal to Nz. Now, 1 implies. From 1, you will get P into Ln equal to Q into Mn. Mn means Nz plus Gm. Gm or Mz, these are all same. P into Ln is equal to Nz. It is given in the question. Q into Nz plus Gm or Mz. This means P by Q equal to Nz plus Gm divided by Nz. You may write like this. This means P by Q equal to 1 plus Gm by Nz. Or from this, I am writing here. P by Q minus 1 equal to Gm by Nz. This is number 3. Suppose this is number 3. From 1, we have established this relation. Now from 2. Implies. From 2, you will get Q into LZ. LZ means Ln plus Nz equal to P into Mz. Mz or Gm, same thing. Mz or Q. This means Q into Nz plus Nz. P into Gm. This means Q 2 times of Nz equal to P into Gm. This means Gm by Nz. Twice Q by P equal to Gm by Nz. Suppose this is number 4. Gm by Nz. Suppose this is number 4. From 3 and 4, the right hand side equal Gm by Nz. From 3 and 4, P by Q minus 1 equal to twice Q by P, or multiply by PQ, you will get P square minus Q equal to twice Q square, right? Multiply both sides by PQ. This will be P square. It is not Q, PQ. PQ. Multiply by PQ. This means P square minus PQ minus twice Q square equal to 0. Equal to 0. Let me write. This means P square minus twice PQ plus PQ minus twice Q square equal to 0. Q square equal to 0. This means P into P minus twice Q plus Q into P minus twice Q equal to 0. This means P minus twice Q into P plus Q equal to 0. This means P minus twice Q equal to 0. Since P plus Q is not equal to 0. P and Q are like parallel process. They cannot be equal to 0. Like parallel process. The resultant P plus Q, resultant of P and Q is P plus Q. It is not equal to 0. This means P equal to twice Q. Good. Good. So far today we have solved 7 problems. Dear students, perhaps you have enjoyed that class. Thanks for attending the class. Thank you very much. Thank you.